Hey everybody. Looks like I've got 6 or 8 people in here maybe. Um, I don't know how many of you can use the chat on Twitch. But if you have questions, you can either put something in the chat on Twitch. I'm monitoring that because I kind of see me looking around here. I got multiple screens up here. I'm monitoring Twitch on one screen, and I've got Discord general chat up on the other screen. So if you have questions while this is going on, please feel free to post something there. And I'll try to make sure to look around every once in a while and kind of check in how things are going. Looks like we got a few people in the chat, so that's good. All right. So thanks for trying to join in if you could tonight. I was kind of in the looking through the general chat and the roller coaster tycoon chat, the SPSS discussion chat room. There were some discussions there about some things that could maybe cause some issues if we keep thinking in that direction. And I want to make sure that we're not thinking too far ahead of where I'm hoping that we stay for a little bit. I want to make sure we don't get ahead of ourselves and start thinking about things too advanced too quickly, because understanding things at this basic level at the beginning is really fundamental to build on it. Even though I know all of you have had EDUC 613 in the past, I also know that sometimes things don't happen the way that we hope they would, and you forget a lot of things from a year ago, especially when you haven't even probably thought about it since then. So I just want to do this as a check-in. So how's the sound for everybody? Is it loud enough? I can crank it a little more. I got a cloud booster connected here, so let me know if it needs to be louder. And hold on just 1 second here. I'll be right back. I gotta go put up a sign, make sure nobody comes knocking on my door here. Hold on. All right, I'm back. Okay, now. All right, let's go ahead and get started. So here's the description from the assignment. To use the roller coasters data set to report center spread and shape of the excitement variable for both custom and non-custom roller coasters, and include histograms for both, as well as a side-by-side box plot. So first of all, I saw some people talking about p-values in a way that I was a little unsure about. So first of all, the p-value discussion that I've had in some of the previous videos was about whether or not a data set was normally distributed, which may be different than how you've talked about p-values in the past, which is in relation to statistical tests like a t-test or an ANOVA. And in those contexts, you're comparing one mean against another, and you're using some formal statistical reasoning in order to make sense of whether there's a difference between groups or not. And in this case, I want you to not go to that yet, because I want to make sure that we really develop those ideas well so that they make sense, and that all of the output that's associated with these ideas will make sense to you. So when you're thinking about p-value, I don't want you to be jumping to considering p-values associated with statistical tests. Another sort of disclaimer that I want to add in about that is there's also some discussion about correlation, which we will talk about later. And at this point, I don't want to dig into that. And correlation is one of those words that's used really frequently in sort of the everyday experience of people. So when we talk about that word in statistics, it has a really specific meaning. And so don't try to dig in and actually run correlations at this point, because I want to make sure that I've scaffolded your thinking well enough that that idea makes a lot of sense when we get to it. And so let's stick right now with just thinking about in the context of these descriptive statistics, mean and median, standard deviation and interquartile range when we're thinking about spread. I saw a question earlier, when we're thinking about spread, are we thinking about more, are we thinking about just the range? And the answer to that is no. Spread means a lot of things. So when you think about spread, I want you to think about spread as standard deviation, as interquartile range, as range, or even as other types of subranges, such as those that you can see in a box plot, that bottom 25% or the top 25%. Whereas interquartile range is the middle 50%. So it depends on where you're focusing your attention. All right, let's go to SPSS and think about this for a little bit. So in SPSS, the question was about excitement. Let me go back to the first question again, make sure we get this right. Center spread and shape for excitement of custom and non-custom roller coasters. Okay. So if we go to Analyze, Descriptive Statistics, and Explore. So this is kind of where I want you to live for the moment, is right here in this Explore. And we're going to put excitement in the dependent list. And if you want to, you could run that by itself just to see what excitement looks like across all the roller coasters, regardless of whether they were custom or not. And then go in and add the custom design into the factor list. Okay. And I'm actually going to export this as a HTML. I think that has been easier to look at. All right. Okay, so we see, like we have before, 43 and 99 roller coasters, nothing missing, which means all the roller coasters have an excitement rating. And let's look at the statistics. So we see a mean of 6.89, a median of 7.19. So there may be some differences here. This difference is really small, although it could indicate some skewness. Remember that the mean is pulled in the direction of the skew, away from the median. So since the mean is less than, we're assuming that there's some potential slight skew to the left, with a tail on the left side. And I saw some people talking about this row here, about the 95% confidence interval for the mean. Please ignore that for now. That is not something that is useful to us. We are not jumping to inferential statistics at this point, or at least not in a formal way. This 95% confidence interval for the mean is talking about if we were considering this to be a sample of some larger population, which at this point we're not. We're just simply comparing the groups that exist already in the park. So if you think about that, it kind of is, in some ways, doesn't make sense to think about some larger population. Because really our sample size in that sense would be one. There's one park that one person created. Unless we're thinking about what other types of things might Nolan Conaway have created that we don't know about yet. But that is even a little different. So we don't have a sample of his roller coasters. We have the entire population of his roller coasters. So for now, ignore this. We're not ready to even talk about confidence intervals yet. I want to build up to that a little bit better. The trimmed mean around 7. Standard deviation 1.32. And remember that this is plus or minus around the mean. So if you kind of go both ways around the mean, then that's a distance of about 2.65 or 2.64. Minimum is around 3, maximum is close to 10. So that gives us a range of a little bit over 6. The interquartile range is 1.71. So that's seems pretty small in comparison to the total range of 6. That 50% of all the roller coasters, the middle 50% of them have an excitement rating that has a range of 1.7. So from the 25th percentile up to the 75th percentile, there's a range of less than 2. So there's definitely a lot of stuff happening at least at one end, if not both ends. It's unknown at the moment till we see what the data looks like. And these skewness and kurtosis values, so I know I've talked about these, but let's talk about them again. So skewness and kurtosis values are measures that tell you about how, well, of course, skewness is about how left or right skewed it is, how much the actual mode or the highest peak deviates from the exact center of the plot. So if they are clustered on the left or the right side of the plot. And kurtosis is a little bit different than that. It has to do with how steep the peak is wherever it is that it peaks. So if it's super steep, then kurtosis will be high. If it's really, really gradual increase up to that the highest point, then kurtosis value will be really big in the negative direction. And it looks like I have a question over here. If I understand you correctly, I shouldn't be focusing on, for example, the upper bounds of the confidence interval. Yes, that's correct. For right now. Right now, I don't want to focus on the confidence interval portion because we're just considering this as the population rather than trying to estimate the population. We have the population of roller coasters, so we don't need that at this point. I hope that answered your question. Okay, so skewness, when it's negative, the tail will be on the left side. When it's positive, the tail will be on the right side. When it's 0, it's perfectly symmetric, meaning the left and the right half of the graph are identical. That never happens. Kurtosis, if it's 0, it's exactly like a normal model would look, which a normal model has a specific equation to it. Don't make fun of me for this. I actually had it printed on a coffee mug, as you can see here. That is the equation of a normal curve, where the little mu M looking symbol, U with a little tail on it kind of thing, is the mean. The sigma in the bottom of the top of the denominator, and actually in the bottom also is the standard deviation. And E is the constant E, which has a never-ending decimal value. So it is a curve that is explicitly defined. And so these skewness and kurtosis values are based on that being 0, whatever that would be. And how much it deviates from that. This is a measure of how much it deviates. Okay. Don't think of these as precise things that are black and white. Everything in statistics is gray. The skewness and kurtosis values here should, by a rule of thumb, be within plus or minus 2. However, that doesn't necessarily mean that if they are not, that they are that there's something bad happening. It also doesn't mean that if they are within plus or minus 2, that you should think everything is just okay and you should proceed. You need multiple points of evidence to make a decision. So let's look at the, I left the stem and leaf plot in there. Nuts. Okay, let me rerun this with the stem and leaf plot, because the stem and leaf plot is not the greatest thing to pay attention to. And I forgot the normality plots. Actually, let's run that one more time. I don't want all this other stuff in there. Okay, export. There we go. All right, tests of normality. This is where p-value becomes something that we want to talk about. In the test of normality, this is a statistical test that involves a p-value, which is this column called SIG period, sig, significance. And in this case, this is assuming that the data are from a random sample, which we're not really thinking of them that way, although you could theoretically consider a possibility that that could happen. But what it's saying is that among lots of different possible samples of values that would have a mean and standard deviation of the kind that we got, the ones in this descriptive table. So for excitement on the default, things that had a mean of 6.9 and a standard deviation of 1.32. If you consider all the possibilities for things that could give us those values, the likelihood of getting one that looks like ours, that has the skewness and kurtosis that we have in our set of roller coasters for the default non-custom group, the chances of that happening, or I should say the likelihood of that happening by chance, is 0.2. So 20% of all possible samples that have a mean and standard deviation like our value, like our set of roller coasters does, 20% of them will look like our sample or more skewed or more kurtosis in either direction, right? So that doesn't seem that unlikely. It's not so small that we think that this isn't normal. So what we're making a judgment about in a way is the larger group of things that this comes from. So this is a piece of evidence, and maybe it's sort of going in the direction that I kind of cautioned you a little bit ago with the p-values, because we have really are thinking about this more as a population. But I do want you to start making sense of what these values mean. And these two different tests, I don't know what just happened there. I accidentally changed the text somehow. This was the something like that. For some reason tend to refer to it as the Smirnoff test. It makes me think of that for some reason. These two tests are used because sometimes different sample sizes have different influences on how sensitive the test is. So, but both of them are giving us values that are pretty large for the significance, which means that we shouldn't be concerned about this data being non-normal. On the other hand, on the custom created coasters, this actually is not 0. It's rounded to 3 decimal places at 0. A p-value of 0 is actually not possible in reality, but only in theory. So this value of 0 is telling us that it is less than 0.001, which if you think about that as a percent, that's less than 0.1% of all the possibilities that would be as extreme or more extremely deviated from the normal distribution than our data set would be. So this is telling us that we probably should expect some deviations from normalcy that could be problematic in statistical tests. And in our particular context of thinking about this in terms of descriptives, it's telling us that there's some skewness likely happening here. So we're expecting something closer to symmetry with the default and something farther away from symmetry for the custom. That's all this is really telling us. So if we look at a histogram, you can see this curve that you could sort of imagine drawn over this. It does have more data kind of on the left side here, which is telling us that this does have some left skewness with excitement of 3, 4.8. So 2 roller coasters that have really low excitement. And then we jump up to this level of excitement that goes in the range of a 5 to 6, or 5 to just below 6, it looks like. With a peak at between 7 and 8 of about 16 roller coasters, it looks like. So the shape of the graph is skewed left. The mean is at 6.9. The median was a little bit higher, if I remember right, at 7.1 or 7.2, something like that. So that helps us understand the skewness. The mean is shifted to the left side of the skew, sort of this direction from the skewness. So helps us make sense of that with the picture. And we can see the total spread here is pretty big, from 3 to 10. And of course, if we look at the custom ones, there are more of those. And some people in the Discord chat were talking about this cluster of things down here on the left. So we would refer to this as a bimodal distribution, which this set of things down here is different from this set here. So those are important to pay attention to, because it means that perhaps we should be looking at this as a separate group. So we could actually create that in SPSS and analyze that separately, although there's not many things there. Looks like maybe, I don't know, four or five roller coasters there. Okay, and then standard deviation 1.1. And if you look at this without that piece there, it looks pretty symmetric. So it's this cluster down here that's throwing things off. And then I'm going to leave you to think about these normal QQ plots from looking at the last video. Think about how those are helping you understand normality. And then the box plot here at the end, I'm also going to leave that to you to think about how you want to interpret that based on your the way that you want to answer this research question. So the second question was about Nolan Conaway saying that custom roller coasters are more exciting than the stock roller coasters. So think about all of the evidence that you have. Weigh the evidence against one another. Think about, what does this evidence say? Are there contradictions in the evidence? Are there certain things that you think you can say, but you aren't sure if really it pans out in reality? Or if you take another set of evidence along with it, then it seems to not be true. What are the conditions in which your answer to this question could be true? That is the grayness of statistics, trying to understand all of the data in its inconsistencies. I hope that I've helped answer some of the questions here that have come up in the Discord chat. And if there are specific things you want me to expand on, let me know, and I will make some other videos that focus just on those topics. And although I will not be necessarily consistent in the chat tonight, I will try to be in there. If you have something that you think is important for me to think about, tag me in it with the @ symbol. It will notify me so that I can make sure to follow up on those things. And I hope this has been helpful for you. Please keep talking in Discord. This is how we can understand how I can understand what's going on in all of your minds that I can't see, and it makes the non face-to-face component of this more easy to navigate through. I don't want to go faster than people are ready for, and I want to make sure that whatever thinking we're doing is productive and helps us work towards something to help you be successful. So keep commenting in there, keep tagging me in things, keep asking hard questions. There's no such thing as a wrong question. All of you have backgrounds that tell me that you have things going on that I need to know about in order to make sense of how you're thinking to help you move forward in that thinking. So my specialty is in thinking about how people learn, and that's what I'm trying to do here. So help me make sense of that. I've been where you are, so I empathize with it, and I will keep doing this as much as possible to help you get there. And I'll see you guys soon. So see you over in Discord, and the chat is going to be turned off here on Twitch, but please chat in Discord. All right, bye.